Hi, welcome to this week's lesson on irrational numbers. We're going to have our title be irrational numbers. Let's get out our spirals and be ready to take some notes on this. Include two vocabulary terms and your, what is it called? Your notes about estimating with irrational numbers. At the end, don't forget your summary as well. Okay, here we go. We are going to estimate with irrational numbers. So irrational numbers are numbers that cannot be written as a fraction. You know how rational can be written as a over b, irrational cannot be written as a over b. An example of that would be the square root of -2. The only way you can really find that other than kind of estimating would be to put it in a calculator, so it's going to be irrational. Another example is the square root of 37. If it was square root of 36, we'd be good to go. Square root of 36, 6 times 6 is 36. It would be 6, so you know it's about 6, but it's not exactly 6 because it's square root of 37. It's irrational. Rational numbers are decimals that are going to go on forever without any repeating pattern. They're going to just keep continuing. So if you do a square root of a perfect number, like 4 or 36, you're going to get an exact answers. Irrationals, you square root and you don't get an exact answer. Okay, so let's work through how we might actually estimate these rational numbers. An example here, we could try the square root of 10. Now again, if you did the square root of 9, you're good. It's a perfect square. 9 can be 3 times 3. Square root of 9 is 3. So we're going to use that information to help us estimate the square root of 10. You've got to think about the numbers around it to decide what you think the square root of 10 would be. And hint, hint, I kind of gave you a close answer of what it's going to be near, simply thinking of the perfect square for 9. You got to think about what's below it and what's above it. So I kind of think, okay, 9 is a perfect square. 3 times 3 is 9. 4 times 4 is 16. So it's got to be less than 4, and it's got to be bigger than 9. So it's going to be somewhere between those two amounts. So we're going to look at all those different amounts here and see we're starting here with our 9, and then we're working all the way up to 16. So 4 is the perfect square of 9, and 4 is the perfect square of 16, 3 is the perfect square of 9. So we know it's going to be closer to 3 than it is to 4. We know it's somewhere in between there. So that's going to give you a good start on what you're actually estimating. So it's close to 3 there on the number line, but it's not quite there to 4. So it's got to be somewhere on our number line closer to 3. It's got to be around here-ish. I would have said to the left more. I wonder if I could move. Nope, it's not going to move. I would say it's a little more to the left. So when you actually put that in there, there you go, little more to the left side. And so you're thinking, what decimal is that? It's going to be like 3 point, maybe 1-ish something. It's got to be approximately around there because it's, you know, there's 1, 2, 3, 4, 5, 6 other numbers that would squeeze in the middle here. So it's going to be closer to that 3, but not quite exactly at 3. And then if we work it out in our, where is it? So that would be your approximate answer there. If you can estimate it at what is approximately, you're going to do just fine with our irrationals because you're going to be able to start putting these into your calculator. So here would be another example, square root of 38. Again, think of what's around it. We just talked about 36. 36 is our perfect square. So 36 was square root of 36. What times itself gives you 36? 6 times 6. So it's got to be close to a 6. So we're counting up until you hit that square root. So that's, your squares are 4, 9, 3 times 3. I got to write it down as I go. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. So obviously I think we're going to be closer to 36, giving us an approximate of being closer to 6. And that little squiggly line there, remember, that means the approximately. We're not trying to get an exact number here. If you want the exact number for an irrational, you're going to have to put it in your estimate. So when you're looking at whether it's higher or lower, it's obviously closer to 36 than it is to 49. So we know what two numbers it's between. It's between 36 and 49 because those are our two perfect squares. That same number times itself gives you the perfect squares. So let's see what that would be. Oh, I just made myself bigger. Can I make myself smaller again? No, we're gonna stay big. Can I do it if I click here? Oh, I'm over here on this side. Oh, it's over here. Yay, I'm small again. Okay. Did you have to count up more? No, we had it. We stopped at 36. So we're gonna pick what it was closer to, 36. Let's start with smaller numbers. We have a square root of 5. So 3 times 3 was 9. Okay, we're already too big there. 2 times 2 was 4. So it's going to be between the perfect square 4 and the perfect square 9. So there's 9 over there. And then there is the square root of 4 is 2. So estimating, is it closer to 4 or is it closer to square root of 9? If it's closer to the square root of 4, it has to be closer to 2. Excellent. You can see on the number line, that will help you to estimate what the square root of 5 would be. It will be approximately 2.1. That's going to give us a good estimate when you put it in the calculator. Oh, I guess, where do you think it goes? Yeah, I'm thinking it's closer to 2.1. Not 2.2, not 2.3. I wonder if I put it in the calculator. 5 divided by 5. No, square root of. What times itself would give you there? So if you did like 2.5 times 2.5, that would be too big. Okay, next problem. Let's just move on to that one. All right, so what if you had, for example, a estimate where you have to do the square root of 24. Okay, so think for a minute about what are the perfect squares that are around there and use the number line to help you. I'll give you a moment to try and, this is in my way. Can I move it to here? Oh, I'm hiding it. Maybe that works. Did I disappear now? Okay, so there it is. Okay, so basic thing at the end here, remember math is everywhere. So as you are working through these irrationals, make sure that you're just kind of estimating with those perfect squares, those perfect numbers. Decide what it's close to, and you'll find what it estimates as. There was some definite vocab that we went through here that you should have been able to come up with 2 vocabulary terms. Make sure you've got your notes in there with a couple of examples. And if you don't see it written, you can always write down sentences in your notes that we say out loud. It doesn't have to be something that you see written on the screen. Then at the end, let's do our summary, unless you're trying to do it Miss Ryan style, where you do the summary a couple days later. Just make a note of that, and we'll still give you credit for that if you're doing the Avid type thing. All right, everyone. So let's go ahead and get this in our notes and have it done before we come to class on Thursday so that everybody gets to participate. Thank you.